Hello, I'm Sai Nikhileshwar. Today I'm here to present on the topic application of finite automata in search engines. In this presentation, we are going to see about automata, finite automata, types of finite automata, applications of finite automata, search engines, application of finite automata in search engines, string searching, and pattern searching. Let us see about automata. Automata is the theory of abstract machines and automata, as well as the computational problems that can be solved using them. It is a theory in theoretical computer science. An automation is an abstract self-propelled computing device which follows a predetermined sequence of operations automatically. Automaton consists of states and transitions. As an automaton sees a symbol of input, it makes a transition to another state, according to its transition functions, which takes the previous state and the current input symbol as its argument. Automata are used as finite representations of formal languages that may be infinite. Automata are often classified by the class of formal languages they can recognize as in Chomsky hierarchy, which describes a nesting relation between major classes of automata. Automata play a major role in the theory of computation, compiler construction, artificial intelligence, phrasing, and formal verification. An automaton runs when it is given some sequence of input in discrete time steps. An automaton processes one input picked from a set of symbols or letters, which is called an input alphabet. The symbol received by the automaton as input at any step are a sequence of symbols called words. An automaton has a set of states. At each moment during a run of the automaton is in one of its states. When the automaton receives new input, it moves to another state based on a transition function that takes the previous state and current input symbol as parameters. The automaton reads the symbol of input word transitions between states until the word is read completely. If it is finite in length, at which point the automaton halts, at a stage which the automaton halts is called the final state. Now let us see about finite automata. A finite automata is a simple idealized machine used to recognize patterns within the input taken from some character set or alphabet C. The job of an finite automata is to accept or reject an input depending on whether the pattern defined by the finite automata occurs in the input. A finite automata consists of a finite set of n states, special start state, a set of final states, set of transitions T from one state to another labeled with characters in C. Finite automata is the simplest machine to recognize patterns. The finite automata or the finite state machine is an abstract machine that has five elements or tuples. It has a set of states and rules for moving from one state to another, but it depends upon the applied input symbol. Basically, it is an abstract model of digital computer. The following figure shows up some essential features of the general automation. Here in the image, we can see the input is taken into the states of automata and the output is generated accordingly. Deterministic finite automata is also known as DFA. In DFA, for a particular input character, the machine goes to one state only. A transition function is defined on every state for every input symbol. Also in DFA, null value or epsilon move is not allowed. That is, DFA cannot change its state without any input character. For example, the DFA in the image consists of alphabets 0 and 1, except the strings with ending with 0. There can be possible DFAs for a pattern. A DFA with a minimum number of states is generally preferred. Here, uh, 0 and 1 in the circles are known as the state. These and the arrow pointing towards the 0 is the start state, and the one with the double circle is known as final state. Non-deterministic finite automata. NFA is similar to DFA except the following additional features. Null move is allowed. It can be moved forward without reading symbols. Ability to transmit to any number of states for a particular input. However, these features do not add any power to NFA. If we compare both in terms of power, both are equivalent. Due to the above additional features, NFA has a different transition function. The rest is the same as DFA. In NFA, if any path for the input string leads to a final state, then the input string is accepted. For example, in the above NFA, the multiple paths for the input string 00. Since one of them paths leads to the final state, 00 is accepted by the NFA. Now we'll see about applications of finite automata. The applications of these automata are given as follows. Finite automata is used for designing lexical analysis of a compiler, for recognizing the pattern using regular expressions, for designing the combination and sequential circuit using Mealy and Morey machines, used in text editors and implementation of spell checkers. Second, pushdown automata. It is used for designing the passing phase of compiler, for implementation of stack applications, for evaluating the arithmetic expressions, for solving the tower of Hanoi problem. Third, linear bounded automata, also known as LBA. It is used for implementation of genetic programming and also for constructing syntactic phrase trees for semantic analysis of the computer. Fourth, turning machine for solving any recursive enumerable problem, for understanding complexity theory, for implementation of neural networks, for implementation of robotic applications, and finally for implementation of artificial intelligence. Search engines. A search engine is a software system designed to carry out web searches. They search the World Wide Web in a systematic way for a particular information specified in a textual web search query. The search engine are generally presented in a line of results, often referred to as search engine. Results pages (SEPR). The information may be a mix of links to web pages, images, video, infographics, articles, research papers, and other type of files. Some search engines may also mine data available in databases or open directories. Unlike web directories and social bookmarking sites, which are maintained by human editors, search engines also maintain real-time information by running an algorithm on a web crawler. Thus, a search engine is a platform on which a user can search the internet content. Google, Yahoo, Bing, Baidu, and DuckDuckGo are popular search engines. In search engines, there are two types of processing: index processing and query processing. Now, we'll see applications of finite automata in search engines. There are many applications wherein finite automata is being used in search engine and for searching purposes. The two main applications amongst them are string searching and pattern searching. String searching is used with the algorithm of DFA based, and for pattern searching, finite automata algorithm is used. String searching with DFA based algorithm. A lot of algorithms have been designed for the task of string searching. Also, some of the first string searching algorithms were developed on the deterministic finite automata, which promotes the need of thoroughly research and investigate how this principle is applied. The DFA approach is used to overcome the problem of backtracking, which is faced with the brute force approach, thereby improving the time complexity. the speed and efficiency of search engine and results obtained. And there are a quite number of search engines searching algorithms, string searching algorithms, and they are of importance in areas as data processing, information retrieval, text editing, word processing, linguistic analysis, and also in areas of molecular biology such as genetic sequence analysis. String searching, let us take an example for string searching. Let text t equal to C B B A B A B A B A B A C A B A and a pattern P equal to B A B A. Both the finite alphabet they consist of three languages A B C. The pattern B A B can be found in text locations 3, 5 and 10 respectively. A string searching algorithm has the task of efficiently locate the pattern within the text in minimal time with minimal usage of storage. The Boolean string matching algorithm compares a pattern symbol by symbol in each and every location of the text. The DFA has string searching algorithms. A finite automated search engine follows certain steps such as constructing a DFA for the pattern, performing the search. Each character in the search is examined just once. In sequential order, when searching is done, a state transition table for the automata is created to represent the state transition function. Given a text T1, T2, T3 till 3Tn, where I represents the index of text symbol such as I less than or equal to sorry 1 less than or equal to I and I greater less than or equal to n and a pattern P1 P2 P3 until Pm where J represent index of pattern symbols such as 1 less than or equal to J less than or equal to M where M and M are the lengths of the pattern and the text. The most efficient solution of the string matching problem are based on finite automata. The ability of the finite automata to eliminate the problem of the text backtracking has influenced the development of the first linear order string searching algorithm because it also preprocesses pattern in O of m time complexity and runs a search in O of n time complexity. The DFA is today used as a tool for string searching because of its efficiency. Pattern searching. Pattern searching is an important problem in computer science. When we do search for a pattern for a string in a notepad or a Word file or browser or databases, pattern searching algorithms are used to show such results. In the FA-based algorithm, we process the pattern and build a 2D array that represents a finite automata. Construction of finite automata is the main tricky part of this algorithm. Once the finite automata is built, the searching is simple. In search, we simply need to start from the first state of the automata and the first character of the text. At every step, we consider next character of the text, look for the next state in the built finite automata, and move to the new state. If we reach the final state, the pattern is found in the text. The time complexity of the search process is big O of n. A number of states in finite automata will be m plus 1, where m is the length of the pattern. The main thing to construct a finite automata is to get the next state from the current state for every possible character. Given a character s, x, and a state k, we can get the next state by considering the string part p p dot minus 1 of k, which is basically concatenation of pattern characters pat of 0, pat of 1, pat of k minus 1. and the character X. The idea is to get length of the longest prefix of the given pattern, such that the prefix is also suffix of path 0 to k minus 1 of x. The value of length gives us the next state. Number of states in finite automata will be m plus 1, where m is the length of this. The main thing is construct finite automata. We can get the next state by considering the string, which is basically concatenation of the string characters pair 0 and 1. Thank you.